Hello, in this video I'm going to explain to you the basics of testing of hypotheses. If you can follow these basics and if you understand these basics, you should have no problem in using any of the tests in statistics. First step is to understand the null and alternate hypothesis. I will start with the alternate hypothesis. And here is how I define the alternate hypothesis. Anything that you want to examine, verify, validate, conclude, or determine is your alternate hypothesis. And the alternate hypothesis is the result of your research question. Let's say in this case I want to examine if the 30-day revenue of a single item of all the Ross stores in a city exceeds $40,000. So that is my alternate hypothesis, excuse me. So what is my null hypothesis? Anything or everything that is opposite to the alternate hypothesis is the null hypothesis. So my null hypothesis is less than or equal to $40,000 because my research hypothesis is greater than $40,000. Okay, so how am I going to do this? Of course, I'm going to collect the sample, and based on this sample, I'm going to determine which one I'm going to support. Now, there are two items that I would like to mention to you. One is the testing of hypothesis. You do not determine which one is true and which one is false. That is not the objective. The objective is which one you are going to support on the basis of your sample. That's all. You cannot determine which one is true and which one is false. Okay. So, let me just simplify the null and alternative in this case to explain the process to you. So let's say alternate hypothesis is 40,000 and the null hypothesis is 30,000. We know that X bar follows a normal distribution from the central limit theorem. It follows approximately a normal distribution with mean mu and standard deviation sigma over square root of n. So if we look at the sample distribution, it is going to look like this. If the null hypothesis is true, if this is true, your X bar distribution will follow this. If that is true, distribution of X bar is going to be like this. Now, you do not know which one is true, and you only have a single value of X bar, and you have to draw the conclusion based on where this X bar is. Now, it is logical that if you observe your X bar on this case, you should have no problem in not rejecting the null hypothesis or believing that this perhaps is the case. On the other hand, if your value, observed value, is here, you should have no problem in rejecting the null in favor of the alternate. Problem comes here. When you observe the value here, you don't know which one is true, because if you observe a value here, it can be true that it is from the null, or it could be true that the sample came from the alternate distribution. So, how are you going to make that discrimination? Well, you are going to make a cutoff point right here. This is called point of demarcation. And it is made in such a way, you can see there is only certain percent of the values when the null is true will belong to this area. This is called level of significance. And every question you're going to have level of significance given to you. It is represented by alpha, which is the probability of rejecting the null when it is true. It is also called type 1 error, and usually it is 0.05, but it could be any number, 0.01, 0.005, depending on what your research is and how much risk you are willing to take in rejecting the null when it is true. Okay. So now if we convert the distribution of X bar into Z, your Z distribution is going to look like this, and this cutoff point will going to be right here in this arrow mark. So what is this value that you're going to determine? It's called critical value. So the critical value means this is the value above which, in this particular case, only 5% of the z value will belong, and to the left, 95% of the z value. And here is how we are going to determine the critical value. Equal to NORMSINV, left parenthesis 0.95. Because 95% of the z values are to the left. So I'm using NORMSINV formula in the Excel cell, and when I type, I got 1.65. So this value right here is 1.65. So your distribution is going to look like this, 1.65. So that means only 5% of the values are to the right of 1.65. 1.65 is called critical value, and this is called critical region. Critical region is same as alpha. Alpha is same as type 1 error. Type 1 error is same as the probability of rejecting the null when it is true. Now, when you read all of those in different sections of the book, don't get confused because they are interchangeable. Okay, so next step, I'm going to calculate the z value from my sample data and available information to see where that z value fall, on this side or that side. So I'm going to say here equal to 34 minus 30, I'm assuming null is true, right? Divided by SQRT 225 divided by 42. Okay, enter. I have 1.73. So 1.73 is where? To the right of this 1.65, right? So I'm going to reject the null hypothesis, knowing that my type 1 error is 0.05. So I'm going to reject the null hypothesis. So what are the steps involved? First is to determine the null and alternate hypothesis, and then determine the test statistic. Test statistics is going to depend on what information is available to you. In this case, you have X bar, and you have the sigma square and the sample size, and so on. Okay, so what is the next step? Your next step is to determine the critical value. How are you going to compute the critical value? You're going to compute the critical value based on the test statistic that you're going to use and the level of significance. Remember, ZINV or norms INV formula I use because it is only applicable to Z distribution. Sometime you may have to use T distribution, so you're going to have a different formula to find out the cutoff point. Next, you are going to do the calculation to find the value of the statistic, and then you are going to draw the conclusion. And conclusion is going to be either you are going to reject the null hypothesis or you are going to fail to reject the null hypothesis. Now, we discussed the right-sided test because my alternate hypothesis was greater than 4. It is possible that my alternate is less than some number. If that is the case, then I will do a left-sided test, lower tail test. Critical value will be on the lower tail. Or I can have a two-sided test. For example, I want to examine mu equal to this some number, and mu is not equal to that number. Mu is missing right here. So just take a note of that. Mu is some number and mu is not equal to that number. So in this case, you are going to have two-sided test. Okay? So based on your alternate hypothesis, you can have right-sided test, left-sided test, or two-sided test, and all of those tests is going to require you to complete these 5 steps. Okay? I hope you find it useful, and if you need any other help, please put a comment below. Thank you. Bye.